Hi guys, my solar snowman here is running on a water battery. Copper strip, magnesium strip and tap water. Now in theory he shouldn't be working because there's not supposed to be free ions in the water to transfer the charge from one to another. But clearly it works, so clearly the tap water is not pure water. It's got something in there that's allowing the ions to flow across. Now, I had a go yesterday using the water out of my dehumidifier. That should be, well, it's distilled water. It's water that's evaporated, been condensed on the dehumidifier, and then it drips into the tray. So that should be pure water with nothing in it, unless there was something in the container. And when I tried that, initially, nothing happened, which is what I expected. But I then found that I had a poor connection on the negative lead. And when I fixed that, it started working. So it was working with the water from the dehumidifier. So this time I've bought some proper de-ionised water. That was £2.49 for 5 litres in Lidl. Obviously far more than I need, but it was the cheapest way to buy it. I didn't actually use the solar snowman. What I used was that butterfly, which is currently just about running on an avocado stone. So I'm going to disconnect him from there, connect him up to here, which is again a copper plate and a magnesium plate. Then we'll pour the water in and see what happens. Oh, and if you're wondering, that's a soil battery. That's just soil out of the garden. Again, a copper plate, magnesium plate, and that's running that clock. Anyway, I'll put the camera on the tripod and then I'll pour some water in there. Well, set it up and then pour some water in. I'll just run through the setup. We've got negative of the butterfly connected to the magnesium strip. We've also got negative going to the meter there. That's on the volt scale. Positive of the butterfly is just here at the moment. I haven't connected it to the copper because I wanted to demonstrate there is a bit of capacitance in the circuit there that's slowly dying away. So I didn't want to confuse things by the fact there is some power in that capacitor. If we connect that up to the copper, ignore that, I just knocked it with my hand, and connect that one. I want to connect that to the connector, to the crocodile clip. Right, so we're connected, and at the moment we're showing 0.275 of a volt. Just adjust that so it's happy. Right, we'll let that die away for a second because it is moving because I've just touched it. Yeah, that voltage is slowly dropping away. What I'm going to do now is pour some de-ionised water in there from here and see what happens. Right, voltage is rising, so we have got some power transfer. This thing needs about 0.7, 0.8 of a volt to get going. Oh, what I could just do, don't want to confuse things too much, I'll disconnect the flower again and just measure the no load voltage. Right. So that's without that drawing any current from it or any power. We've got about 1.2 volts with our de-ionized water. I'm not seeing any bubbles forming on the magnesium strip. So 1.2, 1.23. And then if we put the load back on it again, right, we drop back to about half a volt. So that's de-ionized water. We're not getting enough current to actually get this thing fired up. We could leave it. Last night when I was trying this, I left it for half an hour just to see if it built up enough power in the capacitor to start rocking. So yeah, I'll do that now. That's why the clock's there. I'll speed it up, but I'll come back in half an hour just to see what state we're in. Well, I've left it for about 20 minutes. I suppose if we look really hard, there's the slightest bit of a twitch. But what I'm going to do now is just drop a bit of vinegar in there to demonstrate the difference with a few free ions floating around. Where can I do this? Okay, see the voltage rising? And away we go. Oh, I think that more or less demonstrates what I wanted to say. Distilled water, it doesn't work. Distilled water, de-ionized water. There was still clearly some current flow, but putting the vinegar in there made a lot of difference. I'll just disconnect the flower and we'll measure the no-load voltage. So if I stick that one up onto the copper and disconnect it from there. So just short of 1.7 volts. So that's just measuring it straight across the battery with no load. Put that one back on there again. And the reason it's bouncing up and down is the capacitor keeps charging and discharging on the circuit board there. Yeah, pleased with that. That'll do. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.